All right, so we've got a triangle we're trying to solve for the missing pieces here. So I'm just going to draw a generic triangle so I have a visual to go with it. Let's see, so side A is going to be 45, angle A is 71 degrees, and side C is going to be 47. So if we take a look, kind of walk around the perimeter here, I'm going to encounter the 45, the 47, and the 71, right, as I walk in the order. So this is a side-side angle. And so we know that this is also referred to as the ambiguous case, because there is a possibility that we could end up with 0, 1, or 2 triangles that come out of this thing. So we need to keep that in mind as we're doing our work here. So this can be done either with the law of sines or the law of cosines. I prefer the law of cosines because it will create a quadratic equation which will have 2 solutions to it. Whether those are both viable solutions for the problem or not is a different story, but at least it'll remind me to look at that and consider those values. Law of sines will not do that, and if you overlook the idea of a possibility of 2 triangles, you're losing out on half the question. Okay, so I'm going to go with the law of cosines here. So I would have 45 squared equals to b squared plus 47 squared minus 2 times b times 47 times cosine of the side opposite that 45, which is just 71 degrees. Okay. Notice here there's only one variable, okay, so I can actually solve for it. It's b and b squared, but it's still just a single variable. So to get this thing to be a quadratic, I'm going to go ahead and move everything to the other side. And so I've already done the calculations here. So I've got a 0 over here, I have b squared. Okay. And when I do 47 squared minus 45 squared, minus 45 squared, I end up with 184. So here I'm going to end up with negative 94 cosine 71 degrees times b. And then now I have that left over the plus 184. Okay, so it should be a quadratic. I've got my squared term, my linear term, and then my constant. So I have this as a quadratic. I'm going to do this all on the calculator here. And so remember, none of this stuff is going to be done by, or none of this calculation is done by hand here. So let me open my calculator up here. And I'm going to go ahead and graph this thing. Now keep in mind, this is a quadratic, so I should end up with a parabola. Okay. So let's see, get rid of that stuff here. So I have b squared, so I'll do x squared minus 94 cosine 71, close my parentheses, x plus 184. Okay, and I need to make sure that I'm actually in, no, I was in radians. There we go. Always good to check. Change it to degrees. And I have in y2, I have y equals 0. Okay, so I'm good there. So for this thing, remember, our just agreed upon window is that if my x min is going to be like negative 100 and x max being positive 100. It doesn't really matter about the y values. As long as I can see the x-axis, I'm good. Okay, so I'll graph this thing right here. So you can see right here that I have in this picture the 2 x-intercepts where the 2 blue graphs, or the 2 sides of the blue graph intersect with the red graph. So to find those intersections, we just do second trace, intersect, option number 5 there. Hit enter twice, because there's only 2 equations there anyway. And then I just want to move the cursor so it's closer to one than the other, and just hit enter. Okay. So this is an exact value, or as close as we're going to get here. So 8.22. Okay. And then the other one that we're going to have here, and do the same process, second trace, intersect, enter, enter, and then I'm going to move my cursor over towards the other one. Hit enter, and I get 22.38. Okay, so those are my 2 values here. So here I have b equals to 8.22. And then the other scenario is where b is going to be 22.38. Okay. Both of those are numbers that work. They're both positive numbers, so I can actually have 2 triangles here. Okay. And so all we do at this point is split this whole thing off and just do the work to solve for these 2 triangles. I like to redraw my triangles with that new value put in there. Definitely not something you have to do here. 47, this is 45, 71 degrees. And now I'm saying that side B is going to be 8.22. Okay. I'm going to ignore the second case over there on the right-hand side for right now. But then I'm just going to go ahead and work through and solving this triangle here. So once again, depending on how you do this, you could do this with the law of sines or law of cosines. If you do the law of sines, though, you're going to ignore one of the sides and end up doing a side-side angle. So it could lead you astray. My suggestion here is that you don't do that, but instead you go ahead and use the law of cosines. Yes, it's more work, but I'm going to avoid any potential issues here with law of sines. So 47 squared plus 45 squared minus 2 times 47 times 45 times the cosine of angle B. So that's opposite the 8.22. So I'm going to type this all into my calculator here, subtracting all this stuff here. And what I'm going to end up with is negative 4166.43. So I'm going to round that. We want to try to avoid rounding in the middle of the problem if we can, but here we're stuck with it. So I'll just do the best that I can in terms of rounding. Okay? That's going to be equal to cosine of B. Okay? So remember, to solve for an angle here, when you're doing trig, you're going to go ahead and use inverse trig. So inverse cosine of this expression here, 43 over negative 4230. Negative 4230, and that's just going to be equal to B. So I typed that right in my calculator here. So I'll do that for you here. So here I'm going to do second, I'll quit out of this thing here. So second cosine, and I'm going to type in 4166.23 divided by, and remember, I don't have to worry about the negatives because they're both negative here, but you can put that in if you want to include that, and hit enter. So I get 9.96 approximately there. So that means that angle B is 9.96 degrees. Okay, so I've solved for 1, 2, and the third thing I have here is to solve for angle C, which I'm just going to add 9.96 to the 71 degrees and subtract that from 180 to give me 99.05 degrees. Okay, and so that'll get you your values for the first triangle. The second triangle, the work is exactly the same. The only thing that's going to be different here is that instead of 8.22, I'm just typing in 0.38. Okay. Everything else is the same. All the calculations, all the work that I'm doing in the calculator. So I'm going to skip a lot of that stuff here, but let me write out the equations. We have that 45 cosine of B. Okay. So I'm going to do all the exact same work, and in the end, I'm going to end up with angle B being 28.05 degrees. And then C will be 80.95 degrees. So I've got both triangles here, and that's the whole problem. Hope that helped.